Okay. Alright, so we're live. Hello. Welcome. Guten Abend, good evening. My soul, man, my soul. Lately I've been, my head. So many things to think about. Oh, you know what? Recruiter reached out to me. I've been getting stuff from recruiters lately. What did I do with that? Yeah, there we go. Yeah, as a recruiter reached out to me. Should probably shoot him an email. This fellow. My soul, man, my soul. Wasted like 2.5 hours just now watching, more like 2 hours, 2.5, more like 2 hours watching, other people. Oh, what did I even do? Just watched, there's a show that I like to watch every now and then. It's called the Raj Patel Show on Twitch. I think it's pretty funny. It's very entertaining. Then what else did I do? Watched a couple things on YouTube. Well, there were always videos of stuff going on. You know, there's all this Antifa stuff that happens. So people on YouTube are always... Excuse me. Yeah, there are all these protests and counter-protests and just... I'm always curious. I can't believe, I can't believe what people are doing, what's going on. This one was not so, bad. Actually, it was kind of touching. Kind of showed that these Antifa guys are they're quite misguided, and it really showed that in this video. Actually the guy interviewing them managed to get some of them to laugh, which I thought was really, it's good to see. Excuse me, don't attribute to malice what you can attribute to ignorance. Never a truer word spoken. Never a truer sentence spoken. So yeah, you'll have to forgive me. I'm really tired, worn out, something like that. So we'll continue our Clojure problems. Keep working on this, slowly but surely. Try to get through as many as we can. Try to get through all 156 problems, and I'm also kind of, I don't want to say I'm worn out or depressed or whatever you want to call it, but it's become clear to me that the Clojure videos that I make, not too many people are that interested. Which is okay, I guess. I mean, it's fine, so it's alright. It's alright. Like I said, you gotta do the things that people are interested in. Yeah. Otherwise, you're not gonna get attention if that's what you want. I would have liked it, not that I wanted it, I guess. I'd kind of go in there knowing I wasn't going to get that, but it would have been nice. Excuse me. Oh boy. Yeah, I'm tired. Anyway, so we'll get back to it. We'll continue. We're almost done. We got, only got a few problems left. Once we're done, we'll figure out what to do next. There's boatloads of things to do next. There's tons of stuff, tons of things. One of the things I think I've been thinking about doing is there's a gym across the street from where I work, and I can get a gym membership, and then after work I can go hit the gym before I come home. I think that's a good idea, because I kind of miss doing pull-ups, And the thing with exercising is that consistency is really the thing that makes the difference. Gotta be consistent. Excuse me. Excuse me. Yeah. Let me continue here. Let me continue. So we'll start with reading the problem. Love triangle. Hard search data juggling. Everyone loves triangles, and it's easy to understand why. They're so wonderfully symmetric, except scalenes. Those suck. Your passion for triangles has led you to become a miner and part-time Clojure programmer, where you work all day to chip out isosceles-shaped minerals from rocks gathered in a nearby open-pit mine. There are too many rocks coming from the mine to harvest them all, so you've been tasked with writing a program to analyze the patterns of each rock and determine which rocks have the biggest minerals. Someone has already written a computer vision system for the mine. It images each rock as it comes into the processing center and creates a cross-sectional bitmap of mineral 1 and rock 0 concentrations for each one. You must now create a function which accepts a collection of integers. Each integer, when read in base 2, gives the bit representation of the rock. Again, 1s are mineral and 0s are worthless scalene rock. You must return the cross-sectional area of the largest harvestable mineral from the input rock as follows. The minerals only have smooth faces when sheared vertically or horizontally from the rock's cross-section. The mine is only concerned with harvesting isosceles triangles such that one or two sides can be sheared. If only one face of the mineral is sheared, its opposing vertex must be a point. The smooth face must be of odd length, and its two equal length sides must intersect the shear face at 45 degrees, i.e. those sides must cut even diagonally. The harvested mineral may not contain any traces of rock. The mineral may lie in any orientation in the plane. Area should be calculated as the sum of ones that comprise the mineral. Minerals must have a minimum of 3 measures of area to be harvested. If no minerals can be harvested from the rock, your function should return nil. Interesting. So that's a mouthful. I'll try to shorten it. Basically, you're given a bunch of integers in a sequence, which is supposed to represent like a bitmap of integers, an array of integers. And in that array of integers, you're supposed to find the largest possible isosceles triangle for any given orientation of that triangle, right? So like here, you've got this triangle here. It's the largest triangle you can fit in the map of 1s and 0s. And here you've got the largest triangle, right, consisting of only 1s. Here you've got the largest triangle. Here the largest triangle is actually not, it's got a different orientation than these two, right? These two are they've got the right angle, and there's a sort of a vertical and horizontal piece, right? The two legs are sort of on the axis aligned orientation. Here the orientation is not axis aligned. That's the what do they call that? Right, when the orientation is not axis aligned, that is, oh, what do you call that? I actually don't know. Just not, it's aligned on the 45 degree, negative 45 degree axes. And then you've got another, right, another axis aligned. This is sort of the largest isosceles triangle you can find. Isosceles also just means that the two of the sides are equal in length. So there you go, there's another one, and then here you have, right, this is not axis, this is 45 degree axis aligned orientation. This one there's none, and this one there's none, right? So those are the test cases. Now I've already solved this problem, and I'll explain the solution and how I solved it and all of that stuff. So I have already solved this problem. Right, so the solution I went with was just a brute force solution. I couldn't think of something better than a brute force solution. There probably is one, but I couldn't think of it. An optimal solution. The brute force solution is going to be as simple as at every single position, at each position, you're going to consider all the possible triangles that could be at that position. So there's 8 different orientations. I think I hinted at that there's the 4 different axis aligned orientations, and then there's 4 sort of aligned on the 45 and negative 45 degree angle axes. Another 4 orientations in those directions, or there are those 4 additional orientations. So you get 8 orientations, right? And you can sort of loop through every possible position. And then there's also possible sizes. So obviously you can bound your sizes by the maximum of either the size of the bitmap or the number of integers you've got, right? This is not a square that you're working with. You can see that you interpret each bitmap as sort of the largest possible bound. That was another kind of detail, like so 15 means you're going to use 4 bits if the largest value is 15. If the largest value is 31, you need another bit to work with, so you get 5 bits, right? Which makes this is a 5 by 1, 2, 3, 4, 5, 5 by 5, whereas this is a 4 by 5, right? So these are rectangles you're dealing with. So you do need to, for the size, I think you just take the larger of either the number of rows or the number of columns that you're working with. And then what you do is you operate over the triangles in such a way. Yeah. So you loop through each position, and then you would loop through each possible triangle and each possible orientation, right? Multiple thoughts in my mind at the same time. Forgive me. I don't think it's my fault though. I'm not really asking for forgiveness, am I? But I don't think it's my fault. But just have a lot on my mind. So each position you have multiple orientations and multiple possible sizes. And so you just loop through all the possibilities, right? And you end up with rather expensive algorithm. You end up with I thought it was quartic time algorithm, but it's actually cubic with respect to. No, it's quartic. Yeah, it is quartic. Yeah, because the triangle is quadratic. So if this was square as example, then this would be quartic with respect to the side of the square. But it's a rectangle, which means you can kind of just bound it above by the largest side and call it quartic with respect, bound it above by something quartic with respect to the largest side. It's kind of, but assuming that the n and m, the sides of the rectangle, aren't too dramatically different from each other, that's a reasonable sort of way to look at it. So what we've got next is how to code it, right? So the algorithm is, right, you try every possibility, and then what you've got to do is, so there's those 4 different possibilities, 4 different sort of parameters to look at. And the processing you do, you've got to check if they're all in the triangle defined by those parameters. You've got to figure out if there's all ones in that triangle. And what I ended up doing is I said, okay, well, let's loop left to right over each of the columns and check that sort of vertical column has all ones in it for a given triangle. And I said, actually, the approach I ended up going with was you would take your point, get a set of 3 points from that point using the orientation and the size, and then from those 3 points, then you would get 3 line segments, and then you can process from left to right all of those columns that those line segments would be pertinent to those line segments. And then you can find the top and bottom row associated with those line segments associated with that particular column to get you sort of the range of value, that column of values, the range of that column of values that all need to be 1, and then you can just process one by one to check if those are all 1. Just check that. So then you could check each of those, check the column, and then check every column from left to right in the triangle, and then if all that works out, then the triangle is sort of doable, so to speak, quote unquote. Then there's a couple extra ancillary things. One of them being you do need to handle correctly different orientations, right? So you've got the x-axis and y-axis aligned orientations, and then you've also got the 45 degree, negative 45 degree axes, those orientations. And actually finding the correct y coordinates is no, I think so two ancillary things. One of them is finding the y coordinates. It actually works out reasonably well any which way you cut it, because all of your line segments are exactly on the pixel bounds, because all of your line segments will always be either 45 degree angles or vertical or horizontal. So it works out nicely figuring out the y coordinate, the sort of the quote unquote row intercept of your line segments for a particular column. And also, when you try to convert that's like the first ancillary function, is actually getting the correct sort of pixels that represent like the top pixel and the bottom pixel of a row that's cross section of the triangle. The next piece is calculating the area. So once you have a triangle and it's got a certain size, you determine that size is plausible, right? That you can find that size in the bitmap. Then you want to calculate what the area of that triangle is supposed to be, right? Because we only use the size to get the points to then determine if that bitmap contains that triangle. So to get the size, depending on the orientation, half the orientations, the size formula is just the size squared, whereas the other half of the formula is the size is actually size times quantity size plus 1, the whole quantity divided by 2. Sort of like size choose 2. And the deal with that is, or size plus 1 choose 2, excuse me, size plus 1 choose 2. And on top of it, depending on how you loop through all of these sizes, you may even need to increment the size that you calculate that area function on with. And the reason for that is if you say, yeah, well, basically the way that I ended up calculating the size was a little bit different than how you might otherwise calculate it. Like what I did was I said just take the point, the starting point, and then add a certain vector in a certain direction, and then multiply the vector that you add by the size. So a size of 1 would actually be sort of 1 unit out from the middle beginning point, but you include the beginning point in your triangle. So you actually end up with like a size of 1 would give you the vector 1 vector plus the beginning point would give you actually a size of 2 on the side, which is different than a size of 1. So it's a bit of a misnomer the way that I calculated it. So that way, so I had to actually increase the size by 1 when calculating the areas. Nevertheless, to get the correct area, nevertheless, you can show kind of easily where that formula comes from, where the different orientations will give you a different formula. The 45-degree angles, you could think of it as a size of 1 would just be 1 pixel, which is just 1 area. Then size of 2 would give you sort of 3 more pixels right next to your first pixel, right? Because you'd have 1 directly to the right, or as if we're going to the right, I guess it would be my right, your left. But if we're moving directly right next to it, the beginning pixel, there would be 2 more pixels sort of fanning out to give you 3 pixels, because that's, you're moving in on the 45 degree, negative 45 degree and 45 degree lines. So you end up with 3 pixels. Then you move again, you get another 3 pixels plus another 2, right? And you have this kind of shape. You end up with 1 plus 3 plus 5 plus 7, etc., which is actually a summation of odd numbers, which we happen to know the formula for that is a perfect square. And indeed, you do get a perfect square, right? 1 plus 3, 1 is 1, 1 plus 3 is 4, 1 plus 3 plus 5 is 9, 1 plus 3 plus 5 plus 7 is 16, etc. So that's where you get the size squared value from for that orientation. The other orientation, the axis aligned, or x and y axis aligned orientation, you end up with the normal base times height over 2 formula for triangles, but because you are dealing with pixels, all of the pixels directly on the diagonal, it's, instead of being half the area, they're going to be the full pixels area, which means you've got to take exactly the number of pixels on the diagonal, and what you would do is you would add those pixels and then subtract half of that, or alternatively add half of that. And as it turns out, the number of pixels on that diagonal is exactly the size, because this is a 45-degree angle. So there's, each pixel represents sort of 1 step up and to the left, or up and to the right, or whatever direction you're going in, this 45 degree or negative 45 degree or what have you, whatever, depending on, there's 4 different directions it could be. So you just take size over 2 times size over 2, that's base times height over 2, right? We're dealing with a square, so size squared over 2, and then add the size over 2, which then you can factor out the size to give you size times quantity size plus 1, then the entire thing divided by 2, or size plus 1 choose 2. So that's how you get the 2 area formulas. That's the other ancillary function required. And we solved, I really got stuck coding it the other day. I really got hung up on coding it, and I looked at it again when I had to, like I said, between sort of in my spare time at my job. So I'm not always working on something. Usually I am, but it depends. If I have some time here and there, I'll poke around at one of these problems. and there's kind of like always work to do at the job at my job, so I'm not like, I don't spend all of my time um, learning about the software there, because it's kind of like like I said, it's kind of endless, the amount of stuff to learn. So I don't really like, I basically have an option between like endlessly learning or like learning something that I'm more interested in. It's like, you know, kind of, I appreciate the software that I work on, but it's usually what it comes down to is it's not really learning like particularly interesting or useful things. It's more like someone else wrote an implementation for something that's pretty mundane, and because they're the ones that wrote the implementation, no one else knows how it was implemented. Not because it's particularly difficult or interesting or whatever, but just because you're not the one that wrote it, so you don't know how it was put together. Another way to express that would be because there's not particularly good documentation on how it was put together, as another sort of way you might express that. It's sort of the only person that wrote it, and they probably wrote it under serious time constraints, so they probably don't have, or they just too lazy to put in documentation. I don't know. A lot of stuff I don't document either, because I'm not even sure. I'm not really convinced anyone else will look at it, or like I said, I'm under serious time constraints. It depends, but I try to document as much as I can. Then there's the problem, like I said, I'm not even sure if anyone will even read the documentation. Who would? You'd have to have someone interested in whatever it is you're working on to actually care enough to look at it. Anyway, so yeah, there's like, I have downtime, so I make use of it, but it's not like technically I could spend more time on the things that I work on at my job, but not really. Yes and no. It's like, you would use the stuff. I would maybe use the things that I'd learned, but at the same time, probably not. A lot of it, I'd say like 99% of the effort that I put in there is like probably would be wasted. Because it's like, well, it wouldn't be totally wasted, but it would be, let's just say not as interesting. Not as interesting. Wouldn't be useless though. Definitely not. I don't agree with that. I think it would be useful, but how useful is like kind of arguable. Like I said, most of the stuff you don't know is not really so much because it's like super complicated or super interesting or super whatever. It's just someone else put it together, so you don't really have the roadmap, so to speak. And a lot of stuff is like not too hard to piece together. Also, like you don't necessarily need to go so deep to figure the stuff out. You can sort of figure things out as they come up, oftentimes. Yeah, because usually what happens is like someone else worked on it anyway. So even if you do figure out what the problem is and what to do, like someone has to implement the next change anyhow to sort of fix it or change it or whatever. And it's like, you only have so much time. You can't really reasonably be like doing everyone else's work, so to speak, because that's what ends up happening. It's like you're basically, if you're the implementation person, then there's all, it's sort of a living thing where there's constantly more stuff, things to improve, things to change, and it just kind of fans out. So you never really like, you kind of got to cut the cord at some point where it's like, look, I'll help this much, identify the problem, point out what could be changed, and then hand it to the implementation guy. It's like at some point you got to cut the make an incision, because it's, then otherwise you become the implementation guy for all these projects, and then everybody else just goes home, and you're overloaded and you can't function properly, and eventually quit. It's like, you gotta scope things out, gotta be careful. Anyway, sorry, I'm kind of ranting now, but I do think about that, like it definitely weighs on me. Like there's a certain, biblically it says, thou shalt not lie, right? Bear false witness. So very, really I think about that. It's like, is it wrong for me to be working on this stuff while I'm at my job? And it's like, I think it's arguable. I think if I asked anyone at the office, they would give you what's called CYA, which is cover your butt, and or CYB, cover your butt, and they would say, oh yeah, you should be, I don't know, diligently hammering away at the 2 million lines of code base to learn it better, I guess, as opposed to learning this. I mean, this, you can kind of argue this is useful though. I mean, it's not a lie, I think, because there was at one point I wanted to write a I mean, actually, honestly, I did want to do this at my job. There was at one point I wanted to write a proper backend, and I wanted to use this language also for the front end for one of the programs, because we had run into a problem that this language is actually built to address that problem. So it's not really lying. It just it doesn't feel right. It just feels way too like. It doesn't feel right. I don't know. It doesn't feel right. Technically true, but I have to be really committed to like, oh, this is why I want to. You know what I mean? Like, it's kind of. I don't know. You are supposed to get something out of your job anyway, but you could argue like, well, it's just the pay. Everything else is supposed to be. Yeah, I don't know. Even that is still kind of not really right, because you can get paid to do a lot of different things. You probably want to get paid for something that's in your interests. Something that you want to do, would like to do, or interested in doing. Can bear something that you can bear, burden that you can bear. Yeah. Kind of rambling now, but it just weighs on me, man. I think about it. Think about things like that. It's like, well, are you lying? Pursuing something more interesting over something less interesting at your job. Yeah, well, I don't know. I think you could argue that the expectations that I have, and I'm, doing what they ask. Doesn't require. Well, I shouldn't say it doesn't require too much time, but it requires more so that I'm there more than it does that I'm constant. I'm supposed to be like at the ready. That's really what's expected of me in the first place, is just be at the ready. Answer phone calls and assist and route. Delegate tasks and route. Make sure things are being taken care of. That's like the primary thing. After that, it's just kind of like we'll help around the office, which, yeah, I mean, this does fit that bill. Like, learning this language, like I said, there was one of the tools that was built that if it was using this language, it wouldn't. There was a certain problem that wasn't fixed for about a year. Using this language, it would have been taken care of pretty quickly. Wouldn't have even happened, actually. That problem wouldn't have even happened. So there is value in learning this. I could write a backend in this, like a proper backend for this program that we've got, which I want to do. I do want to do that. I mean, there's like a whole bunch of stuff to automate that it would be pretty cool to use this to automate. Yeah. So anyway, let me do this. Yeah, so let me refresh this. I'll show you what the solution is. So I think I described it right. Basically, there's a few different functions you need, and you're just going to brute force and calculate the areas, and then take, if there's nothing in the area, like if there's no sort of triangle you can make, it'll just return nil. And then if otherwise you get a bunch of different areas, then take the maximum area you can get. I'll just run this to quote unquote prove I was able to get there. And yeah, and other folks have like more concise solutions. They probably did the same thing. I didn't really look too deeply at what other people did. Obviously, they're like 16 lines of code, which is a lot more breviloquent than what I wrote. But I like having a little more space. Like, I like having things a little more spread out and readable, and it's like a little easier to process. I mean, you can kind of read this off, like, you've got this all right, there's triangle areas, and these triangle areas you get an orientation size, a row column, orientation and size. You get size to area of this orientation and size of all the possible triangles. Where does that come from? Here you got possible triangles. Here you've got this size to area function, right? And there's sort of, it's kind of like work your way backwards through the code to figure out what it's doing. It's a lot, in my opinion, not that it's a lot more readable, but it's a little, it's not, I don't know, I shouldn't say it's more readable than these other solutions. Because I bet these other solutions, being terse as they are probably similarly easy to understand, or would be easy to understand. Give up. Oh, I think he gave up on trying to do it more efficiently. I think that's what. Yeah, give up and use the brute force solution. Give up. I gave up too on not doing a brute force. Let me keep going here. Yeah, but these other solutions are also either extremely, terse, I guess. Oh, it looks like maybe he used a dynamic programming solution. Oh, I didn't think of that. Oh, that's not a bad idea. I'm not sure if it matters though. Yeah, I guess you could use some kind of dynamic programming solution, maybe. Like partially build triangles, and then use what you've already built to build the next triangles. Something like that. And even triangles across orientations. Yeah, that's possible. I bet you if I wrote some kind of recursive function, like recursive, like exponential time recursive function, and then memoized over that function, maybe I could get something a little bit better than, quintic or quartic rather, quartic time complexity. Yeah, okay. Anyway, yeah, I mean everyone's solutions were kind of, long, kind of a lot going on. I like what I did. I ran into so many issues though. There was a bunch of things. One thing was here, you've got this greater than function, which I think the issue I really had is that I didn't test each piece as I wrote it. So that's something to remember for the future. But there were a few details that were kind of like big trip up type things. Like one of them was, I think if you watched the other video, I spent hours finagling with this. But basically this greater than symbol, this will operate if you only give one operand. It'll still be sort of what do they call it, syntactically permissible, and that won't give you the right answer if you forget the 0 here. So I forgot the 0 and I ran into a bunch of issues with this. Then I also had the range I was operating on when I was going through the vertical lines, right? The vertical lines of the triangle. There's a certain range which is somewhere here. Here it is, yeah. This range, right? So is triangle filled, you're going to operate over all the vertical lines if they're filled or not. But the problem is that I was not including the last line in the range, and one of the problems with that is that I was supposed to be excluding triangles that are not in bounds. But here's the issue: if you have a certain size and you say, okay, the size is 5. But the last leg of that triangle that is created by the size of 5 goes off the bitmap, you should return false, that okay, that triangle doesn't fit. But if you don't actually take a look at that last value, that last vertical line, and say it's off of the map, and then you say everything else is on the map and therefore the triangle is fine, then you end up with a triangle that's off the map and too big, showing true rather than false, and then when it shows true, you calculate the area of that much larger triangle, and then you get the wrong answer. So what I had done here is I was trying to be cute, and I mapped second to the values, and then I mapped first and last. No, I did first and last of the points, and then mapped second to those two values, and then applied those to this range. But the problem with that is I needed this ending point of the range needed to be incremented by 1 because it was exclusive. It was supposed to be inclusive, but range is naturally exclusive, so you needed to actually add 1 more value. So I ran into a problem with that. So those are 2 things that were like kind of critically. There's really 3 things that really cost me a lot of time, but they're pretty valuable lessons to learn. And this is the reason why I'm doing all these problems, is because I'm trying to pick up like how do you actually program reasonably quickly in this language. How does one do it? Try to get into something that's kind of comfortable for me to do, that I can understand and follow and sort of do. And yeah, it seems that that's one issue. Is if you're setting up your range, you want to make sure that you've set it up properly. You don't try to do anything cute. Then also when you're dealing with what's the other thing called? When you're dealing with not the range, but the other thing. Right, when you're dealing with possible unary functions that are, in your use case, take multiple operands, but in some cases could just take 1 and still work. You got to be careful, make sure you have your operands in there. And finally, the third thing, the really maybe more valuable in those 2 lessons, and sort of a meta lesson, is that just testing each piece of your code as you go, right? The small pieces. Like if I had tested each of these small pieces as I went, with just a few small test cases, doing that is very good, because that allows you to sort of know if you get some really like, these are kind of obvious, simple problems. You'll see them immediately and can correct them, and then assume that for the rest of your program that the rest of the pieces that you're working with are correct. You end up in a situation where it becomes combinatorially more difficult and expensive to root out the problems when you combine pieces that, if you assumed the other pieces are correct and built on top of them, that's way more difficult to work with than if you simply checked if they are correct first. Right, and obviously the language that I'm working with here, it's more than possible for me to get myself into a sticky spot where I'm either not super comfortable with the language such that I'll create small problems, or I'm not really familiar, haven't really sort of gone through all those mistakes yet, and also the language itself may lend itself to certain issues syntactically, semantically. Right, like I think I mentioned, you might be tempted to kind of be cute with how you set up your range. You might forget to set up sort of your balance checks. And I even actually had the wrong value too here. The logic for this has bit was also incorrect in terms of the bit shift left values. Like so there's like little even things that are not really specific to the language also are you could have small errors, and so you really want to like run through a few test cases on your on the small pieces of code, on each of those pieces. Quote unquote unit testing, I guess. You could write some tests that it's supposed to pass. Yeah, so I would say that's good. There is even a testing framework, I think, for Clojure. It has a whole thing that I read about. Let me see if we can find it. Yeah, there is a unit testing framework built into Clojure, so it's not shouldn't be too difficult. It's just, I think for these problems, there's not really a lot of opportunity to use the testing framework, because there's also a spec, I think. I don't know if spec and testing is the same thing, but it's pretty cool, the spec guide, or the spec. Clojure spec is definitely pretty cool. Yeah, I want to say I read about it, and I don't know if I hadn't really gotten too deep into using it though. I haven't really tested it with anything, or yeah, sort of quote unquote tested my metal. I haven't really messed around with it at all. Could also, yeah, this is really cool. Explain. It's really, really good stuff. Yeah, I think spec is probably what I want to use instead of unit tests. I guess, I don't know. Docs are not enough. Yeah, dynamic languages are a lot harder to understand than static languages. They're a lot less sort of quote unquote documented, a lot less quote unquote inertia as well. All right, so specification and testing, so Clojure spec. Okay, so that's probably what I want. Clojure spec, not really. Yeah, there we go. Also, this test data generation, generative test generation, test data generation, and generative test generation. Yeah. That's what we want. That's what we want. We want this testing, right? Spec is really good for this stuff. Pretty cool. So we can take a look at spec. I guess that's kind of what you'd want to do is use spec to do testing as you're going, and kind of build like what the function's supposed to do, and then run tests on it. Yeah, that's for problems that are a little more. I think for in this context, I think what I do is just run a few manual tests. Don't get into using spec at all, because it just kind of doesn't. There's some problems with it, right? Like one of the problems is this doesn't support their compiler doesn't support more than like a certain version, and it doesn't support like requiring libraries, so I can't like import libraries and stuff. Otherwise, like importing spec and then messing around with it would not be a bad idea. But yeah, anyway, so that was my solution. Like I said, you get the triangle areas by processing over a set of possible triangles. The possible triangles you filter on whether or not there is a triangle there for overall the row, column, orientation, and size pairs. The has triangle says, okay, given a position, an orientation, and size, you're going to get some points using this function, this isosceles triangle function. Those points are calculated here, right? This is that calculation I said. You start with the point itself, and then you add a portion that's multiplied by the size for a given direction. So the orientation is two different directions, and so for each direction, you're going to calculate these points and push them into a vector containing the initial starting point. And then so you get your points, and then you say, all right, get line segments based off those points, which you just rotate the set of points and sort of zip that to get your segments, and then check using the points in the segments whether or not the triangle is filled. The only reason we really do this, give it points and segments, is that you just need the left and right most sort of column coordinates of the triangle. And so there you go. You get these points. Sort the points, so you sort the points here, and then you get this leftmost, rightmost thing, which is what's going on down here. And then you say, okay, if we range from left to right over all those columns that are relevant, and we check that every one of them checks out when you apply this function, which just checks is the vertical line filled over the intersection. So you got to get the vertical intersection on the given the segments and that particular column, which is the column you're looking at, set of columns you're looking at here. Get that vertical intersection, which should be, you know, 2 different row values, and then check if that vertical line is filled for that particular column with these particular row starting points and ending points. And this should be the get vertical intersection was a real nuisance. That was really difficult for me to get that to work properly because there's some edge cases to deal with. And yeah, that was just challenging. I'm just gonna say that was challenging to do. Not really get into too much detail how I did it, but there's some edge cases. There's some checking. You know, there's some point slope form things going on here, and there's also yes, sort of the edge cases. Checking for line segments that have that column in there in the first place, and then depending on what you get there, you either just, you know, you might have a vertical line already. You have to just return the beginning and ending of that vertical line, or you've got a couple different line segments that this is passing through. You could even have all 3 of them passing through, but it's not a vertical line, which is an interesting case where that's why you have a set thing going on here, because you could end up with 3 different line segments and getting multiple y coordinates and the same y coordinate twice, or the multiple row coordinates in the same row twice. So you create this set. So it's a little confusing, but this seems to handle all the cases that you need. Yeah, it's just a simple sort of inbounds check type of thing. And right, like I said, there's sort of a lot of pieces. I don't want to go through all of it, but you know, we did it. And yeah, is vertical line checks if check goes over all the bits for a particular row, a particular column for each row, and a certain column and over this range, and uses this has bit routine, which is abstracted. This is get something from the bitmap, checks if there's a 1 in the bitmap at the given row column coordinate, and then you also always got to have an inbounds check. So when you has bit, you also do an inbounds check, and then you get your maximum size, your number of rows, number of columns. There's a maximum value, which is just the maximum value over the bitmap, the integers that you're given, which is used to calculate the number of columns. Then you get your different orientations. You've got a rotate function. So the way to build the 8 different orientations, you just have you start with D, which is going to help you build the directions, which there's 8 different directions from any given point, right? So it loops from -1 to 0 to 1, and uses a list comprehension over this list for 2 variables, and you just don't include the center. And then you can rotate using a rotate function. You can map for each direction you want sort of 90 degrees to the right, or just a 90-degree rotation. So that's what this is, 90-degree rotation, to give you all of your orientations, right? Just a simple map the rotated direction and the direction. What this does is it maps this what's that called? This anonymous function, which will push into a vector the direction and the rotated version of that direction. So you get your orientations. Yeah, I think that mostly covers it. I think I gave it like a quick synopsis of what's going on here. Obviously, it's kind of involved to go through every detail, but that's like most of the details. So yeah, not too bad. Not too bad. But yeah, I mean, definitely you got to kind of test your code as you go, and then with Clojure spec, you can sort of build this a little bit of a spec as you go as well. Okay, moving on. Next thing. So tree reparenting. Now let's go to 128. This I think I solved. This is not. This is an easy question. Easy question. Standard American deck of playing cards has 4 suits. spades, hearts, diamonds, and clubs, and 13 cards in each suit. 2 is the lowest rank, followed by other integers up to 10, then the jack, queen, king, and ace. It's convenient to humans to represent these cards as suit rank pairs, such as H5 or DQ, the heart 5 and diamond queen respectively, but these forms are not convenient for programmers, so to write a card game, you need some way to parse an input string into meaningful components. For purposes of determining rank, we will define the cards to be valued from 0, the 2, to 12, the ace. Write a function which converts, for example, the string Sj into a map of suit, spade, rank 9. So spade, suit, and then jack is rank 9. 10 will always be represented with the single character T rather than 2 characters 10. So diamond 10 should be DQ, heart 3 should, or HS should map to that. This isn't just, oh, okay, yeah, 5, right, because it starts at 2. And then C ace would be club 12, right? And then they said, okay, if you took all of these 6 things of, looks like spades, all the spade cards, you should end up with just get the rank of those spade cards after applying your function. You should just get 0 to 12. So it's a pretty easy question. My solution could have been a lot more succinct, but first thing being this S could have just been AB, which is I could have destructured S right here as an input rather than destructuring it here, and then I defined a suit map. I defined a rank map. Right, each one takes a character, returns a spade, heart, diamond, club, or 0 to 12. And then I said, okay, you're going to return a hash map that has suit map with apply A to suit to get the right value, and apply B to rank to get the also similar to the right value. This could have been made, like I said, more succinct by using one destructuring here. So I could have moved this over there, and then I also could have. I didn't need to use a let. I could have just put this map directly into my return function, sort of like here, replace it directly. And I also could have used for the suit, I think I would have kept it this way, but for the rank, you could have defined the map only for these cases, and then said use a default value, right? So it's sort of like a get, where if the get fails, which it would, if it's a number, and then instead of using all these numbers in the map and making a very big map, you could have just used the difference between whatever the character is that you've got, converted to an integer, and then subtract, also converted to integer, what 2 is, right? So if the character is 2, then the difference between 2 converted to an integer minus 2 converted to an integer is 0. And then you can see why converting the value b to an integer and subtracting each of these values would give you 0 through 9, 0 through 7 as desired. So yeah, you could have done that, and that would make it very, very succinct. Much more, what do they call that? Much more compact solution. Which would have been good, but that's not how I did it. So yeah, that's that. Pretty simple. And then finally, and probably just going to read this and then leave because I only wanted to spend an hour, and it just took a lot of time just to even explain the other problem, that 127. So every node of a tree reparenting, every node of a tree is connected to each of its children as well as its parent. One can imagine grabbing one node of a tree and dragging it up to the root position, leaving all collections and connections intact. For example, below on the left is a binary tree. By pulling the C node up to the root, we obtain the tree on the right. All right. Okay, we'll just read the problem and try to understand it before we go, and maybe think of a solution. Note it is no longer binary, as C had 3 connections total. two child and one parent. Each node is represented as a vector, which always had at least one element, giving the name of the node as a symbol. Subsequent items in the vector represent the children of the node. Because the children are ordered, it's important that the tree you return keeps the children of each node in order, and that the old parent node, if any, is appended on the right. Your function will be given two arguments: the name of the node that should become the new root, and the tree to transform. One more time. Node is no longer binary, as C had 3 connections total. Yeah, that's true. Each node is represented as a vector. At least one element giving the name as a symbol. Subsequent items in the vector represent the children of the node. Because the children are ordered, it's important that the tree you return keeps the children of each node in order, and that the old parent node, if any, is appended on the right. Old parent node is appended on the right. Excuse me, your function will be given 2 arguments: the name of the node that should become the new root, and the tree to transform. All right, so they give us a picture, so we can ponder this. So A, B, I, C, D, E, F, G, H, right? And they said, okay, C becomes the new root, so C, D, E. So what's interesting is it looks like you swap with A, right? Like, oh, no. A, so B, so this is the thing, is it looks like A goes down to be a child of B, and C, right, you swap A with C. So A becomes a child of B, and C becomes a parent of everything else, I guess. So B now becomes a child of C, right? This is a pretty interesting situation where C goes on top, and everything beneath A. So A swaps positions with C, it looks like, except the branch that had C, A actually becomes, yeah, you don't actually, it seems like you don't move that branch. That was the idea that I got when I was reading the input and the output. It looks like you're going to swap, you're going to swap the values, and you're going to swap in a special way such that what was doesn't break down the structure of the branch that contains the node that you're swapping with. You only move everything else, and you leave the structure as it is for the things that are sort of contains the thing you're swapping, the sort of lower, so there's an ancestor and a descendant. You're swapping the descendant and the ancestor, and you're saying, okay, all of the things that are not on the subtrees that contain any of the subtrees that contain the ancestor, or rather the descendant, all the subtrees that contain the descendant, you're not going to touch. But everything else, you're going to, when you move the ancestor to where the descendant is, you move all those things with it. And then you're going to take the descendant, move it to where the ancestor was, and it's going to subsume that subtree structure that you did not move, you didn't touch, right? So this C with DE, this B becomes a child of this CDE. So you get CDE B becomes the child of this, and this A being swapped with C, but not taking the subtrees that contain C with it. You get this A, child I, A becomes a child of B, so there's F, A, and then A has I and this other stuff. So B, F, A, child A, I, all that stuff. That seems to be the rules. That seems to be what they're describing, which you basically can take that in English and convert it to code, and to like convert it to pseudocode, then convert it to actual code, and that's pretty much your answer. I'm not sure if there's a more efficient way to do that, because that's like linear time with respect to the size of the tree, and I don't think you really can do this faster than linear time with respect to the tree. I think you probably could even do that in constant time. You may not even need to do this in linear time, and obviously you're not going to do better than linear time, not constant time. So that's pretty good, I guess. Yeah, it shouldn't be too difficult. I don't anticipate this being that hard. Maybe a logarithm. The only issue you might run into is, no, not even that really matters. You kind of do need to identify which. No, this isn't that bad. The one problem you might have, I guess, is you could end up with linear time only because the tree structure is such that you need to figure out which subtrees contain the ancestor you're looking to swap with. And yeah, that could be, because these aren't necessarily balanced trees. Not necessarily balanced trees. You may be expensive to figure out which subtrees you need to, like, which subtrees contain the descendant that you're going to swap the ancestor with, the root node with. I think you can't really get away from the linear time. I mean, obviously, all these test cases don't matter that much in terms of linear time. It should be manageable. But it is an interesting algorithm to think of what optimization you could make to do this. I think that's probably the best you can do, given that it's not a balanced tree. Yeah, because you do need to ultimately figure out which child. It's really the child of the root node. Because once you identify the child of the root node, then you don't really care. All those subtrees are not going to be touched. So you really only need the top level subtree to leave it alone, which is really just that one child of the parent node that you care about. But the problem with that is determining which of those children contains the descendant that you want to work with. You have to loop through each of those subtrees anyway, so you end up with you end up iterating through the whole tree anyhow. It's not really a way to do that efficiently, I think. The other way that is sort of efficient is to go from the descendant to the ancestor. But the problem with that is, like, yeah, you can just technically keep going upwards through the parents, but this structure you're given doesn't really offer that realistically. That's sort of the first problem you have, and then the other problem you have is that could be linear time anyway, so it doesn't really matter in terms of asymptotic time complexity. Maybe average case, it's a little bit better to go up from the up through the parents, but like I said, it doesn't actually. You don't really have that luxury anyway, because it's not like you have the structure you're given is rather rudimentary, the data structure. If you were given something where, like, you could hash if you had a link back to the parent, you could go from child to parent efficiently, right, constant time, and you also had what do they call that, a hash map from the, I guess, the keyword that describes that particular node to the node itself, right? Then you can jump directly to the correct node in the tree, regardless of where it is in the tree, and then take its parents' links all the way up. But like I said, while that can be done, it still gives you potentially linear time complexity, which is you might as well just loop through the whole tree structure if you're going to get linear time complexity. So yeah, that seems to be the solution. It's just first identify which subtree you don't want to touch. Then, while you're doing that, you can also find that particular node that you're going to swap with, and then perform the swap by, I guess, modify. You just modify the children of these nodes. Yeah. Probably do some little bit of footwork, fancy footwork, where you set one thing to be equal to, like you basically save the value of one thing before you destruct or destroy the. Excuse me. You save the value of some of these things before you destroy or destruct to get the final result. That's typically when you swap something, you've got to save one of the values somewhere in unused storage, so to speak. Save it somewhere and then refer back to it, because otherwise you wouldn't be able to, because you've got to destroy the value in some location, so you got to have it saved somewhere else. That way you can go back and retrieve whatever thing it was that you just destroyed, to swap it back to the other position. I realize that's not a very good explanation of swapping, but it's kind of like, if you're going to swap A with B, you can, either way you do it, you could push B into A and then A into B, or A into B and B into A. However you do it, the first pushing, sort of pushing A into B, you want to save the value at B, so that way you can push that value into A. Because if you don't save it somewhere, it'll be gone. It'll be overwritten by A. And same kind of a deal here, what we're going to see with this tree. Yeah, so that's probably going to be my answer for how to solve it. We'll come back to it later. Probably not. I'm not going to do it now. I'm going to head off stream now and head to bed. But yeah, we can definitely as I was saying, solve it that way, and shouldn't be too bad overall, I think. I don't know how bad it's going to be, we'll find out. And then, so tomorrow I'll probably just give you an update on how to solve it. And yeah, we got 20 some odd, less than 30 problems left. 20 some odd problems. We're getting closer. Counting those problems down, man. Can't wait to be done with this. Kind of sick of these problems already. They just, I don't know. I mean, it's a good time, and I appreciate it and all that, but I'm just ready for the next thing by now. I think I've got a pretty good idea, a grasp of how to use the language to solve these problems, and it's definitely been interesting, though. I mean, I've been learning, and it's been interesting. It's been interesting. All right. Anyway, so thank you all for watching. I will talk to you all soon. Have a good rest of your day. Take care.